Okay, it seems that we're live and kicking. And that is indeed true. Okay, good evening, hello, good day to everybody joining me for the third episode of our adventures with the Pandas package of Python. And today we're going to be dealing with the split, apply and combine methodology as applied in many different contexts, from exploratory data analysis all the way up to modeling and implementing predictive analytics to derive information about the future. Before we get into the subject at hand, a few shout outs again. I cannot thank enough all the people, friends and random people that have visited the channels and seen the videos that gave me constructive feedback on how to improve and get better. So thank you very much for this. We're trying to build the infrastructure so that it is becoming smoother, so that it can become smoother and more efficient when it comes to interactions and the subjects. So thank you again to all the people that support and give feedback on the content and delivery. Also people that have supported me on Patreon and otherwise subscribed, so thank you to all of you. We're a young channel trying to deliver content on data science and things related, and thus to this extent we're trying to make it as methodological but also as fun as possible. So with that in mind, let's get to business, because we have a lot to cover and I don't want to make the stream too long or longer than it needs to be. Hey Duck Academy, thank you for joining, and I invite everybody from our Discord channels and otherwise to interact on chat if you have any questions. I'll be addressing them as we go along, so if you have any, feel free to ask them and I'll be happy to answer to the best of my ability. Okay, first of all, I have a question to you. Is the text visible or should I make it larger? Can you read all these elements here, or should I make them slightly more expansive? Is this visible, or I'll make it slightly bigger anyway. Maybe not as big. Yeah, that should be good. Okay, so the split, apply and combine methodology is applicable in all stages of data science projects or data analytics projects from start to finish. So as you can see, it goes on from the data preparation, which means looking into it, grouping them together and doing analytics and descriptive statistics on them group by group. This second idea is the exploratory data analysis in here. So the EDA, I should have plugged in my tablet. Okay. So exploratory data analysis, where we do the summary statistics. By this I mean descriptive statistics. So all the positional measures and the spread measures and all that. So all the means and medians and standard deviations and variances and so on and so forth. These apply here, and we can do that group by group as well. And during the actual modeling, when we fit separate models onto particular groups to do predictive analytics on them. So we apply them to each panel on our panel data, because as you know, Pandas stands for panel data, DA data, S just for fun, so that there is more than one. Okay, so let's imagine a scenario whereby we have to do a piece of analytics on a restaurant where people come to enjoy the food and they bring their families and friends and otherwise try to enjoy the foods that they serve. And they're trying to do some kind of analytics, summary statistics basically for now today, on how well they're doing in terms of both the bills and the tips that the staff get as a result of their interactions with the restaurant. So this is the scenario that we'll be dealing with, and now we have to group the information by various categorical variables. What categorical variables are, we should probably know already, although we'll be going much deeper into the data types from the statistical perspective, not necessarily from the programming side, although that would also be necessary to capture one way or another, so that we are on the same page about both sides of the data as understood by data science and programming. And to this end, what we'll do is try to apply certain strategies, such as map-reduce strategies that you probably have heard of from the Spark or big data context, where the map step corresponds to the splitting and applying of the data, or splitting the data and applying the functions and methods to provide the analytical information about them. And the reduce element corresponds to the combination of the data. And there are two ways to understand the combination of data, as we'll see later. So as you can see from the technological standpoint, not the application standpoint right now, we can refer these strategies to Excel's pivot tables, group by statements from SQL, and SAS procedures, or SAS procedures if you prefer. There is a paper that I'll be providing on it in the description, and this notebook will be available on my GitLab. That is also in the description of this video, so feel free to help yourself and go crazy on having a look at those methods and trying to implement them yourselves. Okay, so moving on, the group by operation. Today is going to be more of a theoretical approach to this methodology, and next week we'll apply it on a particular data set and try to derive this information from as if live, so that you can have a look how it's applicable in practice. That is not to say that today we're not going to be looking at code. I just prepared the code earlier so that we can move on and talk about the methodologies from a theoretical standpoint. Okay, so having the theory in mind, we can split or divide the group by operation into three categories, or three subgroups as it were. The first one would be to split the data, so group them according to some criteria. Apply the functions or methodologies to group them independently, so separately of each other, and combine the results into a data structure or a group of data structures if the modeling stage so desires or requires. And within the apply method or apply stage or step of the methodology, we can aggregate the data, which we'll see today. We can transform them, and there is a particular difference between them. When I say aggregate, for example, we sum them, we derive the means for continuous variables. So values that are not, as it were, in any intervals, they just continuously can adopt every value possible within the range. Or the grouping of sizes or counts in the context of discrete variables. So for example, the groups of sexes, for example, males and females, or days of the week, these would be examples of discrete variables. So the transformation stage is important from a technical application standpoint, but also from the, let's say, more semantic standpoint, in as much as the transformation involves things like normalizing the data. So, for example, changing the range from 3 to 100. I'm sorry, I'm writing with a mouse. Maybe I should actually switch to that. I'll turn it on in the meantime, and we'll take it from there as it turns on. To, for example, a range of 0 and 1 plus minus some kind of epsilon. To have the ranges in the same split, to apply certain computations onto them. So we'll have a look at the example of the Z Score normalization or Zed Score normalization, and how to fill the nans with groups with values derived from each group. So we'll look into that. And then after all this is done, we can actually filter the data even more to choose the particular variables or features or dimensions that we are particularly interested in the context of our project or our analysis. So I hope this sounds like a plan, and let's dive into the details of this methodology. So this is the high-level representation, graphical representation of the method, whereby we have our raw data. Maybe this will work now. Actually, let me just, yes. This will allow us to use our beautiful tablet and actually make the handwriting slightly more legible with any luck. So we take our raw input, this is our raw data, and you can have different, you can see different categories A, B, and C. We group them or split them into these categories X, the feature X, apply a certain method, in this case it's a mean, and then combine this into a data structure by group with the respective means as represented by the original data set. So this is the high-level representation, and in this case we have an example of combining the data in the sense of aggregating them, and you'll see what the difference is between this and the transformations. So without further ado, we shall move on down. I should probably switch to this. Yeah. Okay, so first we split the data. For this case, like I said, the code is ready, so don't hate me for not applying it live. We'll be doing that next week in detail, so you'll have a chance to see me struggle as well. Today I thought the theoretical representation is more important. And we load our data set from the Seaborn library that provides certain data sets in the public domain, and we can have a quick look at what they look like. So we see that we have the total bill, we have tips, we have the division by sex, whether somebody is a smoker or not, the day of the week visited, the time of day, and the number of people that arrived to have this particular meal. A quick look into the correlations and representations of the data shows us, I should probably remove this, yeah, shows us that there is only two correlations, which are, again, not surprising, the correlations between the tips and the total bills. Where is my total bill? Yeah, there it is. Or you can read it, tips here, total bill here. So this and this are the same, right? The same correlations as well, but from the other angle. So total bills and tips. You'll see that this comes into play later on, and we can actually extract this information further down the line. To see them grouped by size. So the x-axis, so the 2, 4, 6 represents the sizes, so how many people, sizes of the groups that arrived to have this particular meal, and then the tips given. So as you can see, the relationships are here. So you can group them and combine them and represent them graphically like this. The first implementation of our group by method is grouping the data frame by the gender or sex, so female and male, and let's see what we get. We get a group by object, and it's very hard to see what's in it because it only represents, it gives us information that a group by object has been created, but there is no output. We don't know what it is that we're looking for, therefore we only have grouped it by the males and female. Let's explore it even further, or slightly more in depth. As you can see, our grouped object has been grouped by sex, therefore we have males and females, represented by indices. So which observations, so in practice, which rows in the data set are represented by males and females. So you can see 0, 4, 11, 14, and so these are observations where the female sex has been registered, and 1, 2, 3, 5, 6, and so on have been for the male. So far, so good. I'm checking the chat and nothing's happening, so so far I can assume that everything is clear. Okay, and since we can spot that this is actually a dictionary, we can interact with the indices as if they were, not as if, as the same way that we do with dictionaries. So we can look at their keys, which is, unsurprisingly, is our sex division, so basically males and females, and also the values, so that our indices, where they're stored separately. So let's have a look at the groupings. The male group starts here and group ends here, and respectively we have females here and ending here. And we see that there's quite a few more representations of males than there are for females, and we have to take that into consideration when we derive the means. That's why we sometimes separate them into groups to have a more reliable descriptive statistics as pertaining to the number of observations, because now we know that there's almost twice as much males as there, or twice as many males as there are females. So by this definition, we should take that into account when we're calculating our statistics. Okay, with this in mind, we can also look at this as a list, and we can interact with it the way we would with a list. So we can index into it, we can filter it in the way that we wish or desire, and what's important is that we get a list of tuples. This is one big tuple of 157 rows and 7 columns, and 87 rows and 7 columns for the female representations of the groups. We can actually have a look at the groups again and get similar outputs. So you can see there's a lot of, what I'm trying to say is there's a lot of ways we can interact with the group by object as presented by the data set, or as presented by the method here. And we can filter by a particular group, so get a particular group, and the difference now is that as we move down, we actually get a data frame back. So not a dictionary, not a list, but an actual data frame that you can actively interact with the way we would normally interact with our original data frame stored as df. So hopefully this gives you a little bit of an insight into the fact that an output with an information or piece of information that gives us information that there is only an object is not scary anymore, and we can actually interact with it in depth using these methods as related to the group by objects. Okay, so this particular stage is done. I'm going to check the chats for any questions. I should probably have some kind of a Discord group open as well, but I don't know. Anyway, like I said, we're learning. We're trying to get the infrastructure right, so that there is, so that the interaction is maximized. Okay, so the apply stage. We looked at the entrance at the beginning of our talk that there are 3 ways to apply various methods and functions to our grouped or group by objects given by Pandas package. We'll see them in action now, whereby we will first split or group the objects or the variables by two categories. The first one is sex, and the other is whether somebody's a smoker or not. Both are binary, so 2 values are expected. And the important parameter that we pass to the method is this as index. And then we do the application. So what is it that we want to see? We want to see the sum of all the groups between sex and smokers. So let's have a look what it looks like and what the difference is between having this parameter as index as true as opposed to as false. You can clearly see that the index, the hierarchical multi-index created by the group by object, is starting by the first group here, whereby if we pass the parameter as index as false, we get a regular 0 indexed index, if you don't mind me saying. We still get the sums, we still get all the other outputs the same way that we would normally. The only difference is that these indices matter, and they're different. So depending on what your use case is, you might actually apply it one way or another. I generally feel that in my practice of, oh my god, over 7 years being in the business, this gives you a lot more freedom and flexibility when applying different models and different functions. So I encourage you to do that first before you decide it was actually a bad idea. 9 times out of 10 it would be a good idea, or will be, speaking from experience. Okie doke. What happens next is that we still grouping it by sex and smoker, who's still given it an index, the first hierarchical index in here. So basically this is our tuple sex and smoker. And we aggregate this because it doesn't make sense, for example, for the size column to be summed up, because we don't care about this much. We care about the counts, or we care about the median, so how many people on average come to this restaurant on a particular day. So we can do that using the AGG, which stands for aggregate, and I can apply the sum to this particular column here, total bill, and in terms of size we can apply the median. So what is the, I don't want to say average because it's not really the average, and you'll see the difference in a moment, but you can actually see and count the groups as they come and see when groups are larger and what days and whether they're smoking or not, and we can group them that way as well. Okay, drilling into this methodology even more, we can see that we can actually create functions, or custom functions I should say, like the variation coefficient, which is getting us closer and closer to the Zed Score normalization or standardization. So in this case, we take the standard deviation and we divide it by the mean. This gives us the variation coefficient, and it has a very strong application in chemistry, for example, analysis of different molecules and particles, but that's really not important. The important bit is that we can actually apply this variation coefficient function that we've created ourselves into our variable of choice, as grouped by the female or male, and whether somebody is a smoker or not. Give me 2 seconds. All right, and we can apply more than one. If we created 3 functions here, we could apply all of them, and we also apply the mean and standard deviation because it makes sense in the context of our function. So our CVN, so the variation coefficient, is in this case the following. You can see that the variation coefficient function statistic has been created, as well as the mean and the standard deviation, and it's under the variable called CVN. So things are building up, things are getting to the stage where we can actually get to the Z-score normalization as we would later require, for obvious reasons that I'll show in a moment. Let's have a look, before we do that, let's have a look at the distribution, the probability distribution of our total bill function, total bill variable, sorry. We get our $19.7. So on average, people paid around $20 per meal. But there is something going on here. You can see that our average is somewhere here, but our mean is somewhere here. So we have this space that we have to work with when it comes to identification, or whether something comes from the probabilities, from a normal probability distribution or not. And we want the variables to be as normal, in inverted commas, as possible for statistical analysis that we can derive later. So there's something to pay attention to here. And you can see that it is right skewed. So the tail on this side is slightly longer, obviously, considering we can't have negative bills, because nobody will pay us to eat there unless you're famous, I guess. Okay, so I'm going to create a new, just to see, df total bill. Just going to have a first few values from 16 or 17 to 25. So there is a bit of a spread there. But since we know that the median here is about, the mean is about $20 or 19.7. Let's group them into two subcategories between where we set the threshold of $20. So now, if we do that, I should remove this. We will get the true false. So basically, we will get what we call Boolean values. So true or false on whether a given observation is valued above $20, in which case we would get true, or below, in which case we would get false. And we can actually map this and take it further and map it to whatever we want. In this case, we've mapped it to the text called over 20 if it's true, or under 20 if it's false. And it looks something like this. So now we've gone from our means through the division or setting the threshold of $20 and dividing into Boolean categories and mapping those Boolean categories into two text values, so over and under 20. Okay, I haven't looked. All right, it's still quiet. Fair enough. Okay, and now you can use this new variable, cat or category greater than 20, in our grouping, which is also very cool and also very important, because this also allows us to categorize the data set according to additional computed variables on top of what we have in the original raw data set. And now we can do computations on it. So now you can see it's divided. The total bill that people paid for, the total bill of over $20 has on average happened 4 times in a week. And in under $20, in 2.3 times. So now you can derive information, financial information, according to different groups, not only the groups that have been originally provided by the data set. So you can see this is just the tip of the iceberg when it comes to the applications of the apply functionality. We'll look into this more as we do the challenges next week to see what other information we can derive from different data sets. But this should give you enough of an intuition on what is possible and what you can do, what you can do and what you should be thinking of from the analytical perspective in terms of what questions to ask and how to go about answering them. So this is a key piece of the intuitive element that we can apply to code or using code to answer particular questions that don't clearly stand out from the original data set that we've been provided with. All right, so this is the apply stage, and I will wrap it up by saying play around with it, use it and abuse it to the best of your abilities, and come up with any crazy ideas or questions that you might have and try to answer them and group them. Because as you'll see, we can actually, as we divide them into 3, we can model them differently in the predictive sense. So you can apply model 1, just do M1, different model here and different model here. This is not a cubed thing, this is M3. And this will also give you more information and more impact in terms of the decision-making process. So that's very cool. All right, so what's the difference between this and the transformation stage? Because they are very much related, but there is a trick to them. Transformations are usually functions that have, again, many applications in many areas, but they're very much used in feature engineering, and you'll see why. Because the data frame shapes, so what I mean by shapes is, for example, you have a data frame that is, what's the shape of our data frame, in fact? We can check that real quick. We have shape. We have 244 observations in 7 columns. And you'll see that, as we have in this case here, we only get two outputs. Right here. Now with the transform method, we apply the same methodology, so we still, in this case, apply the standard deviation calculation or statistic, but look what happens. The standard deviation is applied to all the observations, regardless of how many there are, rather than just having one statistic for one. It's 115, and in this case it's 148, as 2 columns, and that's it. Or sorry, as 2 rows. And we still did the same thing. We still applied the group by, we still divided it by sex, we still indexed it as true. So we still have the same methodology between splitting it and applying the functions. The output is different. The output is exactly the same. So we will have 244 observations in the transform case, form, and we would have 2 outputs in the apply context. So you see, this is why we use it so differently, and this is why it has different implications when it comes to the shapes of the data set and further or later applications of the methodologies in the modeling stages. Right? So that's why it's important to remember this. And now, by the same token, we are now ready to discuss the Zed score. I'm saying Z and Z interchangeably because depending if you're American or British, some of them will say Z and some of them will say Z. Basically what we take is we take the original empirical values, I think it's total bill. So basically these values, this column, as a vector of X, so we would even say total bill. We subtract the X bar, as we say, so this would be the mean. And we divide by the X. I'm going to just put it SDD, no pun intended, as standard deviation. And then you will get the values. Take a look at this, the values here. And after we've applied the transformation, so again, we apply the transformation, we apply the mean, we apply the standard deviation, and we do exactly what I just said. So we divide the column by the mean, and we subtract the column total bill with the mean, so we actually subtract the mean from the column and divide by the standard deviation. And what we'll get as an output is the X normalized variable or column or feature or dimension, if you will, that is roughly between 0 and 1. So the X is roughly between 0 and 1, roughly, right? And we did it step by step to show you exactly that it's applicable to all the columns, all the observations, the entire data set. We still get the output of 244 rows. All right, so that's the important difference that you need to remember when we're doing this. All right, this is the transform bit. Let me check the chat. Still not much going on. Okay. So the last bit that I would like to discuss, and again, I'm going through this rather quickly because we'll see more of it in action next week at the same time. So there'll be more to know and more to expand on next time. So for now, let me just group it in a different way. We group it by day of the week. So when we look at the groups, we have our Thursday, Friday, Saturday, and Sunday. So these are the 4 days that the restaurant's either open, or this is when there was most interest in terms of the financial information from these days, because, and it's not really unexpected, because these are the days where people tend to go out a lot more. And we get the indices of those. So now, let me remove and take it step by step. I'll actually take that. Okay. So you still see that there is even more power to the flexibility of the methodology here, where we group it by the sex, so female and female, and the total bill. We apply the mean, so the average here, and we can select exactly which index we want and which columns we want exactly. So you can even filter down after you've grouped them. You can even drill into the groups themselves to derive more particular and more detailed information on what it is that you're interested in. And I did the round here because you can see the decimal points are ridiculous, so it's actually makes sense to round it to 2 decimal points, right? And we get 21.41. By the same token, we can group them, we can filter out the particular indices even further. And by the same token, we'll get the average total bill grouped by sex according on Thursday or on Sunday or any other. We could choose any other day of the week from the group. This is important. We could choose what Friday we have, no Friday, and get exactly the same thing. So you can see, let's actually finish this and do the Saturday as well. Saturday. So what's happening here, as an example, to wrap it up? The highest total bill by average, or on average, is on Sundays, ironically. Second best is Saturday. Third best, and these are pretty much comparable, is Thursday and Friday. So I wonder what's so special about Sunday, where people tend to spend more than it is about all the other days of the week that we have in our data set. This would be a question that we could investigate further as we go along with the exploratory data analysis. Okay, so this is the theoretical part. I hope I didn't bore you too much with the details, and I felt it was important in as much as the theoretical part is concerned, because this will allow us to have a common language and common vocabulary when applying these methodologies and strategies to our data set next week, or data sets next week, because I'm assuming there'll be a few of them. I haven't looked at this yet, so I don't know, but I'm assuming there'll be a few. So, any questions? Anything that was unclear? Anything you'd like me to explain or clarify or otherwise shed more light on? Let me know either now or later on our Discord groups, Discord chats. We have it in the descriptions. You can also leave a comment, and don't forget to let me know that you liked it by subscribing or otherwise supporting me on Patreon, or we actually have a Twitch channel as well. I don't know. So with that, I thank you very much and see you next time. I'll wait a little bit. All right, so thank you very much, and I shall see you on Monday with our Polish stream at 6 p.m. Central Eastern Summer Time. All right, have a good evening and take care.